Hello students, in this lesson I am going to go through examples of how to write the equation of a polynomial in its factored form if given its graph. What we're going to be doing is, again, we're going to be going backwards to what we had done in the previous video, which was given the equation in factored form. Now we're going to be writing equation in factored form if we understand where the roots are. So, again, this information was given to you in the previous video about the end behavior. If an equation is odd, the end behavior would be opposites. Depending upon what the leading coefficient is, okay, we may be coming from below and then towards positive infinity, or we may be going in the opposite direction if the leading coefficient is negative. Same thing that could be said about the even and odd even functions. The end behavior will be the same, so we may be heading towards positive infinity or may be heading towards negative infinity, depending upon what the leading coefficients are. So here in this case, a is greater than 0, and here a is less than 0. Again, understanding the behavior of the roots, whether or not we have a single, double, or triple root is important so that we can understand how the polynomial is behaving as it is heading towards the x-axis or heading towards the roots on the x-axis. Let's take a look at our first example together. So I have this polynomial. What we need to do in order to write the equation of this polynomial, we need to assess, first of all, whether it's an odd or even degree polynomial, and then second, we need to assess whether or not we're dealing with a polynomial that has a positive leading coefficient or a negative leading coefficient. Judging from this, the end behavior is going to look like this. So therefore, this must be an odd degree polynomial, and the leading coefficient must be positive. Again, how do I know that? Well, that's because this matches the conditions given to you in the beginning of this lesson here. It matches this condition here. And I want to go back to the 6th slide. All right, so the leading coefficient is positive. It's odd. Now we need to talk about the roots, okay? I am aware that at x equals to -2, this looks to be a single root because it just cuts through the x-axis. In its factored form, the single root is going to look like this, x plus 2. The next root I have is 3. This is a triple root. Just again, based on the nature of the way that the graph is drawn. In its factor form, the polynomial will have the factor form be x minus 3 cubed. The last root I have is 4, and this looks to be a single root again. And in its factor form will be x minus 4, not squared. Let's scratch that. It's not squared. Made a mistake. My apologies. So this is not squared. Okay? So if I were to put it all together then, okay, the equation would look something like this. So single, triple, single, this is in fact an odd degree polynomial. Let's take a look at the next one. All right. So looking at this, okay, again, I see that I have odd degree behavior because this is the end behavior is heading in the opposite direction. However, because of the way that in which the graph is heading in the negative, when x is heading in the negative infinity, y is heading towards positive infinity. Okay. This is telling me that the leading coefficient must be negative as a result. This is an odd degree polynomial with the leading coefficient being negative. Next, I know that the roots are at -3, 2, and 1, -3, 2, 1, and 4. So at x equals to -3, this appears to be a triple root. The polynomial in its factored form will have a factor of x plus 3 cubed. Next root is at 2. This is a double root. In its factor form, the polynomial will be x minus 2 squared. The next root is 1. That's a single root. In its factor form, it will be x minus 1. And the last one is x equal to 4, and this is, again, a single root. In its factor form will be x minus 4. When put all together, it's going to look like this. And now notice the leading coefficient here I made negative. This is negative. I could have put in there in the front any coefficient I like, just as long as it's negative. It could be -2, -1,000,000,000. It doesn't matter. The leading coefficient is negative. Okay. Next, judging from the end behavior here, because the end behavior is the same, I immediately know that this is going to be an even degree polynomial. But looking at the end behavior here, I know that the leading coefficient therefore must be negative. And then looking at the roots, I have 3 roots. At 1, this is a double root. And in the factored form, the polynomial will be x minus 1 squared. Next is x equal to 2. That is a single root. In its factor form will be x minus 2. The next root is 3, and that is a triple root. In its factor form will be x minus 3 cubed. Putting it all together, remember the leading coefficient has to be negative, so therefore I place a negative sign out in front. And that is the equation, a possible equation for the polynomial. And again, emphasis on the word possible, because again, I have no idea how high or low these maxes and mins are, and that would dramatically change what the leading coefficient should be. And that's the end.